The average human walking speed is 1.4 meters per second, and I want to find out how many miles per hour this is. I'm going to write my unit conversion as 1.4 meters per second, and multiply by the conversion facts I need in order to turn this into miles per hour. So first of all, I need a conversion fact with meters. On the exam, you would have a table of conversion facts very similar to this table right here in the conversion for unit analysis. So meters, I can turn meters into feet and then go from feet into miles, or I could turn meters into kilometers and then go from kilometers to miles. Either way, I'm going to get the same answer. So let's say I start off with turning meters into feet. So I'm going to use 0.3048 meters. So 0.3048 meters goes on the bottom so that meters and meters will cancel, and that's the same as 1 foot. And then I also need that conversion fact for how many feet are in a mile, and there are 5,280 feet in 1 mile. Okay, so again, you can get that conversion sheet up and look at this right here. 1 mile is 5,280 feet. Okay, so that's going to do some of our conversions. That's going to turn meters into feet and then feet into miles. So my current unit is mile. Now, we want to keep going because we want to turn seconds into hours. So we're going to have another conversion right here. And seconds are in the denominator, so I want to put the fact that there are 60 seconds in a minute. So seconds needs to go on the top on this one so that my seconds will cancel. And keep going. I also know that I need to turn 60 minutes into an hour. Okay. And so just to show that cancellation again, seconds cancelled with seconds, minutes cancels with minutes. So my units, the only units that I have left are miles per hour. So that's what I need. So let's finish the multiplication on this right here. On the top, we are going to have 1.4 times 60 times 60. That my keyboard is not working. Let me try that one more time. 1.4 times 60 times 60. Okay, so on the top it looks like 5,040. On the bottom we need 0.3048 times 5,280. Okay, so 16.09 or 1609.344. And then just finish that division. Okay, so back to my calculator, and we just want to divide those two values. Okay, so I'm going to round this to the nearest hundredths place, so I'm going to say it's about 3.13 miles per hour. Miles per hour. Okay, so that's what I would want to show during my unit conversion. So some of the important things are showing that I've got my unit facts, where I've got the facts lined up. So sometimes it's common to have a bar here instead of the division. That's not a problem. But I want to show that I start with the original, and as I walk through this, I switch from one unit to the next unit, and so on. Keeping this unit now, and I'm switching back, getting rid of seconds. So I want to show the cancellation of the units, and I have my conversion facts here with units written, so I can show that I'm using proper units all the way through. Okay. Let's see. How many kilograms did this baby weigh? To start this one off, I don't think I'm going to finish this one, but to start it off, since I've got pounds and ounces, I'm going to want to convert 8 ounces into pounds. So 8 ounces times, there are 16 ounces in a pound. So 8 times 1 is 8, divided by 16 is a half, 0.5 of a pound. That's going to tell me that altogether, this child weighed 22.5 pounds. So I need to do that conversion first, and then I need to do the conversion that's going to take me from pounds into kilograms. Okay. Now, again, I'm not going to look that up and do that conversion, but that's hopefully enough to get us started on this one. This one had one pre-step of getting this all in the same unit, thinking about what fraction or decimal this 8 ounces would be in terms of pounds, so I could have them all in the same unit. Okay, I could have went the other way and went how many ounces altogether. If I found out how many ounces this 22 pounds was, I could have added it to the 8 and get ounces. I had ounces here, and I had to convert from ounces to kilograms. Okay. I believe that there are 2.2 pounds in 1 kilogram, so if you wanted to finish that multiplication, you could get your answer. Okay. Let's see what else we have. A rectangular vase measures 20 centimeters by 15 centimeters by 30 centimeters. How many liters of water can it hold? Alright, so we know that volume is length times width times height, so it's going to be 15 times 20 times 30. Now, this shape is a rectangular vase, or the box type shape. This is one of the formulas I'm supposed to know, that volume equals length times width times height for a rectangular prism. Rectangular prism is the same as a box shape. Okay, so I do need this formula. And then if I multiply, let me grab one of my calculators, so I multiply those together, we need 15 times 20 times 30. Okay, so 9,000. And that is in cubic centimeters. Okay. Now I want to know how many liters, so let's multiply this by the conversion. Right here we're told that 1 milliliter is the same as 1 cubic centimeter. So again, cubic centimeter, so I'm in milliliters, and then I know that there are 1,000 milliliters in a liter. Milliliters. So altogether I have 9,000 divided by 1,000, so I have 9 liters. So that would be the final answer on this one. Okay. So we've got a couple more of these geometry problems. Okay. So in this figure I have a trapezoid, and I want to find the area. And again, this formula is one of the ones that's a flat shape, so I do need to know this formula. So the formula is that I need to take the average of these two bases. So I could write this down as big base plus little base divided by 2. We're averaging the two bases, and then we're just going to multiply by the height of the figure. Okay. So the area is 16 plus 10 divided by 2 times the 10 for height. Now, I'm not using this 12 at all. I don't need that in terms of finding the area. If I were finding the perimeter, I would find 16 plus 10 plus 10 plus 12. But for the area, I just need the length of the two bases and the height of the figure. Okay. So, let's see. 16 plus 10 is 26. 26 divided by 2 is 13. And 13 times 10 is going to be 130. Units on this are going to be square meters. Okay. Two more shapes right here. We want to find the volume and surface area. Okay. So, this one right here is a box. I do need to know both of these formulas. So, volume, first of all, is length times width times height. So the volume is 4 times 5 times 6. So 4 times 5 is 20. 20 times 6 is 120. Okay. Centimeters cubed would be the units on volume. Right. Next, for surface area, I do also need to know this formula. So the formula for surface area is the area of each of the 6 surfaces in this box. So there's 2 top and bottom, and then there's 2 more for front and back, and 2 more for side and side. So altogether 6. And the formula is 2. And if we do top and bottom first, the dimensions on the top and bottom are length and width. So 2 length times width plus 2 length times height. If we're looking at 2 of these walls, they have dimensions length and height. And 2 width times height. 2 of the front wall, back wall. So width times height are the dimensions of that wall. So it's like the area of all 6 sides. Okay, so my surface area is 2 times 6 times 4 plus 2 times 6 times 5, 5 was the height, plus 2 times 5 times 4. Length and height, or width and height, were 4 and 5. Okay, so altogether on this one, let's see, 2 times 8, or 2 times 4 is 8, times 6 is 48. 2 times 5 is 10, it's 60. 10, 40. Okay, so if I add all of those up, that adds up to 100, so I have 148. And I think the units were centimeters, so since this is a measurement of area, it'll be centimeters squared. Yep, they're centimeters. Okay. So this is my surface area. Alright. For the next shape, these formulas are formulas that if I needed to use them, they would be given to me. I don't have to have them memorized, but having them doesn't hurt. The formula for volume is pi r squared h, and the formula for surface area is 2 pi r squared plus 2 pi r h. Okay, so we'll find each of those. The radius r is going to be 4, the height h is going to be 5. Okay, so my volume is pi times, again, the radius halfway across the figure is 4, so I have 4 squared times 5. Okay, so in this case, it's pi times 16 times 5. 16 times 5 is 80. So my volume is 80 pi. Was I in centimeters? No, feet this time. Okay, cubic feet. Now we can also get an approximation for this volume by multiplying 80 times pi. Okay, so 80 times pi, that's clear. Let's see. This calculator has a pi key, so if I do 80 times pi, 220 or 51 point, we'll say 3. Usually I round to the nearest hundred, so maybe I'll say 3. So 251.33. And that's cubic feet. Okay. Now in the computer, you notice that a lot of times it asks you to first write your answer in terms of pi and then give the approximation. For the paper test, I would actually take either one of these. They're not both necessary, but we do need to make sure that we have at least one of those as our answer. All right. Now my surface area. Okay, so the formula again was 2 pi r squared, and so that r squared is 4 squared, plus 2 pi, which r, which was 4, h, which was 5. Okay, so I've got, this is 16, 16 times 2 is 32, pi, 2 times 5 is 10, times 4 is 40, plus 40 pi. And since those are like terms, they both have pi. When I add them up, I get 72 pi square feet. And again, the approximation for that one, we'll take 72 times pi. 72 times pi. 226.19. There we go. Okay, so there we go.